Okay, hello to all. This is the technology that we have developed with GEES recycling within the Refresh project. We have nearly completed and installed the new mechanical recycling line. GEES recycling makes mechanical recycling mostly of the part low density of the blade, since our process that use particles reduction and then a bonding agent to process is able to process material regardless of fiber, of resin, and of core material, even if it's all mixed. Next one, please. So this is the line, the industrial line that we are setting up now. In this day, it's mounting in our plant of Aviano. It's again something really large, probably one of the largest, or I think the largest in Europe recycling line for composite. It's dimensioned for 7,000 tons a year, not hours, sorry, that's a mistake. With a press size of 550 5 meter 500 by 1 meter 35 with more than 6,000 tons power. Next one, please. What's the challenge? The challenge is, as we see in the before slides of Tandnef and MTB, the wind blades in reality are mostly made of, are in reality two different products. We have the root, we have the transition part, and then we have the wing part. In the wing part, we have much more core material respect composite with respect epoxy and fiberglass. And so what is important, what the challenge was to obtain, use the mechanical process where it makes sense for the low density material, because with our product, with our process, we can maintain and exploit the low density as an advantage, and use the other processes like you see later, the pyrolysis and so on, for the higher density full composite without core material, where also the core material may create problems. We did also some on-field evaluation, because it's very hard to find the real data about the wind blade composition from makers. Next one, please. So the core material makes the waste composite much less interesting, or if it's not forbidden, for the use in cement kilns, because it's a low density. So when we fill the kiln, we will fill with something that is a third of the weight of the mass. Lower the production output in any thermochemical process, and also complicate much the process with unwanted gases, byproducts, and residues. Our proposal, we are using the less interesting parts of blades from the concept of carbon fiber and glass fiber, the less adapted to other recycling process, transforming new materials using our RFM mechanical recycling, and exploit the low density as a value instead than an obstacle. Next one, please. So the new Refresh production line, we will make panels better, faster, and more competitive, with higher performance, and with future alternatives also from a cost point of view, to MDF and plywood. We are doing a lot of research also with SETMA and other partners to evaluate the results of poly recycled panel from wind blade. Next one. What we will need to do, what we will obtain Will it be competitive? I can say yes. Circular economy, for example, building components. We are making recycled components for shading facades and architectural components. 40% light than ceramic, 70% lighter than concrete, 96% recycled content. That makes lower cost, lower cost of installation, lower cost of infrastructure. For example, the, this these these this structure for making this facade, if done with ceramics of the original stone that was intended, had to weight something like 4 times more. Next one. Circular economy, cold chain freezer components. We are already doing a lot of several circular economy projects with companies that works in the cold chain and freezer. First, because it's a field where a composite makes already a lot of sense. In any kind of cold chain equipment, you have always water, liquid, condensation, and so on. And so the resistance, the water resistance, and the sensibility to liquids of our panels is really ideal. It will offer better insulation respect alternatives, no thermal bridge, no rust, and no need for, or much less need to reinforcing. So it's something that it already find a really interesting application field to work on. Next one, please. Third application, construction. Formwork in recycled composite made with our recycled panels and profiles made in pultrusion, and then we will see that probably will be also possible to make the pultruded profiles with some fiber and materials from recycled slate. We are already offering a modular system compatible with the traditional steel and plywood panels, but with really it's lighter. It's a much longer life because again doesn't rot, doesn't rust, doesn't even need to be grounded for current or for flash protection. Next one. Plus, we are also working, and since we are believer in a strong cooperation, and we are obtaining really excellent results with other partners. So one thing that we are working on, and we will see in a couple of months it will be competitive. An entire facade made from profiles from cut with blade, and pultruded profile with the recycled glass fiber from Craft that could be used also for the insulation. Our recycled panel, the blade cut from a TANF, and on and on. Again, something carbon negative, very high recycled content, will be da rispondi. And we think that will be something really interesting for mostly for the renovation of buildings like social housing, where it will be possible to obtain very positive result, low cost, and with also a good thing that this facade will be fully recyclable at the end of its life, again with more or less the same technologies. Next one. I thank you for your attention. I am open to any question and so on.